Alrighty folks, welcome to the third video covering Chapter 4 Section 1 in your pre-calculus book, which again is a comprehensive review of everything you should already know about right triangle trigonometry, taken to a new level and showing what kinds of problems you need to be able to do here in trigonometry. So, all of the examples in the previous videos, well, they were all asking you to solve for side lengths. However, trigonometry can be used in the opposite direction as well to help us find missing angles. What we do here is we use what are called inverse trigonometric operations to solve for those missing angles. The problems are still set up exactly the same way. However, it will be a little bit different when we're going to solve the equations because we will no longer be pulling the variable out of the fraction. The variable will now be within the sine, cosine, or tangent equation. Now, that should not be really something that troubles us too much once we've passed through Algebra 2, because all the way through algebra, we've been getting rid of different operations using inverses. For instance, here's 4 quick examples. In number 1, if we have x plus 4 and we want x by itself, the opposite of addition is subtraction. On number 2, we have x divided by 3. The opposite of division is multiplication. In number 3, we have x to the third power equals 14. If we want x by itself, we take the cube root. So x is the cube root of 14. And in number 4, if we have the square root of x equals 5, well, we can get rid of square roots by using exponents. So x would equal 25. Okay, we've been doing this all along. So when it comes to sine, we need a way to solve for the angle. Now, if you're wondering what this is the Greek letter theta. It is common in higher mathematics for unknown angle values to be represented with Greek letters. It's just a variable. Okay? Now, just like we did in those 4 examples up above, there's always a way to get rid of any mathematical function. They all have inverses or we wouldn't really be learning about them. So for sine, the opposite of sine is known as the inverse sine or arc sine. Now that's notated in 2 different ways. We can either say the arc sine specifically, or we can use the notation sine to the negative first power, but that is mathematics for inverse. That's a mathematical symbol for inverse. It's not an exponent. Okay? So for instance, down here in this equation for the one up above there, if we want to figure out what theta equals, what we need to do is take the inverse sine of each side. Now when we do that, sine and arc sine cancel each other out, which means we have theta equals the arc sine of 0.461. Now this is something else that we just type it into our calculator, okay? If you look right above sine, cosine, and tangent on your calculators, you'll see inverse sine, inverse cosine, inverse tangent in a different color of text. In this case, on your TI-84 pluses, the way we access those functions is we hit second and then the sine button, which you'll notice should bring up the arc sine, and then we type in the decimal, 0.461, and we hit enter. The calculator will then look up the angle measure that has that sine value, which is 27.4516545.2 is where it's rounded off on your calculator. So we would say theta is approximately 27.5 degrees, somewhere in that area. Okay? Again, the rounding is only important if the directions tell us how to round. Otherwise, as long as we round correctly, it doesn't matter how many places we round to. So let's do some more examples of that. So if we want to find angle x and angle y in this triangle, this is an example of how the setup is the same, but the solving is different. If we want to solve for x, x is one of our angles. 6.4 is the hypotenuse, but 10 for x would be the adjacent. So we would need to relate adjacent and hypotenuse. So again, the setup is not any different than when we're solving for a missing side length. We need to decide which of our three trig functions, sine, cosine, or tangent, relates adjacent to hypotenuse. That would be cosine. Then we write an equation. The cosine of our angle, which is x, equals 10 over 6.4. First of all, there's no way that could be 6.4, so we're going to make an executive decision and change it to 64, because 6.4 is too small to be the hypotenuse of a triangle where there's 10. Anyway, so then we type that into our we need to take the inverse cosine, the arc cosine of each side. So we'd have the arc cosine of the cosine equals the arc cosine of 10 over 64. Again, when we do that, cosine and arc cosine cancel, and we're left with x is the arc cosine of 10 over 64. So we type that into our calculator. Second cosine, 10 divided by 64, and we get that x is approximately 81.0 degrees. So we'll go with 81 degrees. For y, we would have to relate opposite to hypotenuse, because for angle y, 10 is the opposite, 64 is the hypotenuse. So again, we just ask ourselves which of our three trig functions, sine, cosine, or tangent, relates opposite to hypotenuse. The answer is sine. So the sine of y degrees equals opposite over hypotenuse. So we need to take the inverse sine of each side. So we have the inverse sine of sine y equals the inverse sine of 10 over 64. Once again, the arc sine and the sine cancel each other out, and we're left with y is the arc sine, or inverse sine, of 10 over 64, which we feed to our calculator. Gives us 8.9892999345. That's a lot of nines. I'm just going to round that off to a 9-degree angle. Does our answer make sense? Well, if we think about it, this is a right triangle, which means the other two angles should add up to 90 degrees, which our answers do. When rounded correctly, they add up to 90 degrees, so it makes sense that those would be the correct answers. Okay, same deal as before. You should probably pause the video and try to find the variable on your own. For those of you who have eyes like mine, that does say 8, that says 13, that says y. This says 11, this says 18, and this says x. So find the values of x and y, pause the video, try it on your own, then resume the video and see how you did. In the first one, we need to be relating opposite to hypotenuse. So when we're looking at this and we're trying to figure out which trig function we should be using, we are dealing with opposite and hypotenuse, which means it's a sine problem. The sine of y degrees equals opposite over hypotenuse. Then we would take the inverse sine of each side. So the inverse sine of the sine equals the inverse sine of 8 over 13. Once again, inverse sine and sine cancel, leaving us with y equals the arc sine of 8 over 13. Type that into your calculator. Second sine, 8 divided by 13. And we get y is approximately 37.97. We'll make it 98 degrees because the next digit's a 9 as well. And again, if you rounded it differently, 38 degrees would have been acceptable, 38.0 degrees would have been acceptable. For x, we have the adjacent, and the hypotenuse, which means we should be dealing with a cosine, because cosine relates adjacent to hypotenuse. Cosine of x is adjacent over hypotenuse. Take the inverse cosine of each side, meaning that x is the inverse cosine of 11 divided by 18, or 52.33 degrees. Would also accept 52.3 or 52 degrees. Okay, keep going. Again, pause the video, try them on your own, and then resume the video to see how you did. All right, let's see here. Let's see, there's a y here. This is 2, this is 7, and this is x. This is x, this is 43, this is 5. So in the first one, for the, let's say we do x first, we would say the tangent of x degrees is opposite over adjacent, or 2 over 7, which means x is the inverse tangent of 2 over 7, which would be 15.94 degrees. Let's go 9.5 degrees, because it's 9.45. Okay? For y, we would also use tangent. However, the tangent of y would be 7 over 2. So y would be the inverse tangent of 7 over 2. Feed it to the calculator. And we get, hark, 74.05 degrees. Those answers add up to 90, so it makes sense that those could be the correct answers. On letter D, we have tangent once again. The tangent of 43 degrees is opposite over adjacent, or 5 over x. Now, we've seen a couple of these before where we were solving for a side length. Don't forget how to do that. I mean, just because it's not an angle doesn't mean it's not something we don't know how to do. So we end up with, we multiply both sides by x, gives us x times the tangent of 43 degrees equals 5. And then we divide by the tangent of 43 degrees. When we do that, we get x by itself. X is 5 divided by the tangent of 43 degrees. Feed the calculator. 5 divided by the tangent of 43. We don't need an inverse tangent because we're not finding an angle. Looking at 5.36 units for the length of x. 2 more. Again, be flexible. We have experience doing all the things we need to do. If you're having trouble with numbers like me, that says 5, that says 12, that says x, that says 3, that says 12, and that says y. Again, pause the video, try them, then resume the video and see how you did. On letter E, we would set up a tangent equation. The tangent of x is 5 over 12, which means x is the inverse tangent, or arctangent, of 5 over 12. Feed it to the calculator. Second tangent, 5 divided by 12, is 22.62 degrees. For letter F, we're again going to set up a tangent equation because we have opposite and adjacent to work with. The tangent of y degrees is opposite over adjacent, which is 12 over 3, which means that y is the arctangent of 12 over 3. And if you want to change that to 4, you can. It doesn't make any difference. So second tangent of 12 over 3 would give us an angle of 75.96 degrees. All right, that does it for our first day's notes over 2-1, which was quite a bit of information. But again, nothing in this entire section of notes should be something you've never seen before. Everything in these first 3 videos is information that should be covered in a basic geometry course. Thank you very much for your time and attention. There will be more videos covering section 4.1 because we still have 2 more sets of notes. We need to talk about the remaining 3 trigonometric functions that you've probably never heard of, and we need to discuss word problems. So there will be more videos for 4.1, but that does it for this first set of notes. Thank you very much for your time.